Student answered the following question. A and B are non-zero real numbers. Prove that this cubic equation has three distinct real roots if this is true. That if means we're going this way. We're starting with this statement, or we're going to be using it at least, and showing that that gives three distinct real roots. So we start with statement one, we differentiate and get this, and this is true when you differentiate it and you can factorize it. And then solving gives x equals 0 or minus 2a over 3. And if you sub back in, you'll see that these y values are correct as well. So 1 is okay. And now we're using the fact that this is less than 0. So what that tells us, yeah, correctly, is that we can forget the 27, to be honest. B and this term here have to have opposite signs. And so one of the stationary points is above the x-axis, one is below. All good. That is really nice. But then it says if the cubic has three distinct real roots, then one of the stationary points is above the axis and one is below. And actually, that's like the opposite to what we're trying to show. Remember, we're trying to prove it this way, and this line 3 is starting to talk about going the other way. So actually, that is not what we should be proving, which means the student's solution is wrong, and they should have shown the converse of the result in step 3. So our answer is going to be E. We need to show that if one of the stationary points is above the x-axis and one is below, which actually it is, then the cubic has three distinct real roots. And yeah, that is going to be the case, because if you've got a stationary point here and one here, then we've got to come down. Actually, sorry, it depends on the cubic. This is a negative cubic I'm drawing. We've got to come down and go back up, and then it's going to come back down. If you had it so it was a positive cubic, so it's like here and here, then it would go up. It's got to come back down. It's got to then go back up. And again, we've got 3. So this student just needs to, I mean, they're basically there with the argument. They just need to say, since the stationary point, since one of the stationary points is above the axis and one is below, then the cubic has 3 distinct real roots. Maybe we could use these diagrams to help them. Okay, and then if we finally look at part 4, hence, oh, they just write in a conclusion, hence this is fine. So it's all about the converse. They've just mixed it up, and therefore, yeah, they just need a slight adjustment, but they should have shown the converse to the result in step 3.